That's why they're not showing it, but maybe when would they come on that in the picture? Yeah. Yeah, what? Yeah. Wait, okay.
Don't worry.
Okay. I think what do I connect it with? This thing. Okay. Is it up? I need to do anything or it's connected?
Not working. Okay, so now we need to go to the control, the display control panel. Control panel. It looks like it. So you got
I didn't see it. It's not seeing that one at all. So it's something else. It's not even recognizing it as this. No, it's just it's a little bit loose there.
Layer 1 issue. It's a layer 1 issue.
Huh?
Layer 1 issue.
Yes,
Layer 1 issues now.
There you go.
We have all kinds of issues.
So there is no second speaker.
Did you try your lavalier mic? Where's all the mics?
Mike, I don't
Right
have.
Okay, that one's gonna be you. Where's the handheld?
You MC. There was one guy wanted to do an announcement. Did you-
Yeah, I wrote that down.
Okay. I just put this on your right there. And right by the second button. Yeah.
Got the
right
Google
above it. That
Hangout
should be
working for
perfect.
you. Check it out.
Okay.
Period.
And then the button, you know, the button is right to turn it on is right
Yep.
on top.
Right,
Switch
yeah.
that sideways.
7:45.
Hi, everyone. No water. No water for speakers. It's much more interesting. Oh my gosh, what a day. Sorry about the food on the floor. A leader right now had a food fight right before you got here. I know you guys saw this one. That's why I told you to come late, because we had this epic food fight. We had to get out of our the tables were clean. I think we wiped those down. But we, I mean, the fabulous team volunteers. There was 300 kids and a couple of their parents who showed up here about an hour ago. And there was a lot of energy in this room. I'm a little exhausted. And it was balloons all over the place. There was a lot of fun stuff. Appreciate the patience and coming a little bit later than our normally planned time. And most of you guys follow instructions really well. I gotta hand it to you. I think you have two guys coming at the normal time and everything
Okay, I
else
think.
later. So good job getting your email and sharing them. And I see a lot of familiar faces.
whatever
Just
browser.
everybody then, hi. I haven't been here for a while. We were doing some summit.
Oh, my sharing went away.
And at, then I was in a little community college student network.
Entire. Oh, maybe actually let me do this.
And,
That may be,
well, hang on,
that may be
it's
better
working.
because then it
Hello,
will know.
hi.
Can it check?
Um,
And if you,
Thanks for
I'll switch
joining
to
us.
the Chrome anyway. So
Yeah.
yeah. Presentation. Sure, we will see this.
Welcome back,
Can you check?
everybody. The, next week from now, wait, Rick? We have a, do we know?
Switch or change something.
Yeah.
Change
let's
the
just-
Okay, I'm sorry, I thought we had a plan.
your
So,
screen.
if you make sure you want to shoot it out, we get an session.
Over here, I see the basic window with all this stuff. So you either have to stay here and just
Yeah,
switching,
you know
or
you're
you
not
might
maybe
be
here on the last
taking full
second,
screen.
raise
Because
your
when you
hand.
reach full screen, that's literally
Okay, if you think you are,
you are not
maybe
sharing
for
that.
the beginner session, raise your hand.
So
Okay.
there's some
Might
slideshow,
be, might be this.
not presenter view.
Oh, you know what you can do? You can read my book. I just published the second edition of my iPod of 5 Days, and Smart People too. It's
What's
on
this
your
presenter view?
and you can download it. Those of you who really just want an intro to OpenStack, you don't necessarily want Rick to go through this intro to OpenStack whiteboard session for the fifth time.
I think this one is not showing up when I do
It
this.
has fun cartoons. I will probably print a few copies and drag them along to somewhere. Anyway, the updated it per kilo, other people helped, Rick, you're gonna kill me, but I put your name in the credits. I did it. So,
It worked?
Can you email the URL?
hppress.com, hppress.com, and it's somewhere on that page, scroll through, it's the only one that I stack up there. Probably the easiest way to get it, I think we have our foundation page from it, it's also super secret. Put the diagram around, h2.com/pod/. But yes. The name of it, oh gosh, it's called OpenStack Technology, Bridging the Enterprise Barrier. I was going to use it for dummy series, and then you tried asking to use them, so I couldn't call it for dummies. But otherwise, we just called it OpenStack. But it's also gets into a little bit some of what HP does for OpenStack upstream and internally with the 92 plan of OpenStack too. But a lot of this is just on the OpenStack Foundation. OpenStack turns 5 very, very, very soon. So, okay, so some upcoming announcements. Do you have questions already? I'm still announcing stuff. All right, now let's start. It's Sean. What do you think of Sean? If you have forwarded my book, we need like the first 4 chapters. Sean did not write the forward to my book. Nobody wrote the forward to my book. I didn't even have Yatsik help me. On the first edition, Yatsik and I wrote it together after you did a lot of writing for Rackspace, a lot of technical writing. But Ghost on me, live in England or something, and so I didn't know. No one wrote the forward, but that's not a bad idea. Although I can't even get Sean to show up here anymore, so I'm not gonna write a forward to my book. Speaking of Mr. Roberts, he apologizes again. He will not be able to make this tonight, which is really long because networking is kind of right in the valley now these days. But we have a great lineup for you tonight and in the future years. So some announcements. Because of your patience and your incredible flexibility, we decided to bring you guys some Slack and some fun stuff. So we have over to our demo gallery. And so we brought some OpenStack shirts. We did this for the 4th birthday for you last year. OpenStack Much turned 5. We thought, we better get rid of these. And also, you guys have been incredibly patient. We also made, I can see from what I'm wearing, like patch for you. We also made a whole bunch of patches of different projects. So I brought down the Unify patches for that's why it's networking tonight. And if you might want to take patches that iron onto your favorite shirt or sweatshirt. If there's a project you absolutely love and you have to have a patch for the project and then you talk to the person to grab. If we make 14 projects, 14 patches, and I wasn't going to grab 14 patches down. So I just grabbed the Unify stuff down. But if you're moving into a different project, you really want to patch for that, I'll grab you one. I also recommend stickers when we were, every time we budgeted for the Cloud Foundry Summit, I bought from our booth drive, we did a whole bunch of fun developer language stickers. So, if you guys are sticker people, I can see my laptop, it's covered. So there's Python, of course, because it's, an OpenStack unit. So, there's also Ruby on Rails sticker, there's Java, there's .NET, there's, oh gosh, PHP, Go, there's like 7 stickers there for languages. So help yourself to a sticker, and if any of those run out, we also have much more about upstairs. I think that covers this one. We have a gift for my dear friend, Java, who has helped us so much for all these years, and this is his last one. And I'm going to try to get this back on because I'm really excited about it. Actually, I didn't think I was going to see him ever again because he told me his last one was his last one. And when he walked in the front door, you guys should have seen it. I didn't have to tackle. But luckily, stronger than he actually picked me up and none of us falling for. So it wasn't that dramatic. But I was really happy to see videos every time. Good back every. I have a gift for him. It's over there. It's the coolest bag of swag ever. There's some dorky stupid stuff in there. There's also some really cool stuff in there. We also have a gift for Rick, because Rick has also been incredibly helpful with this meetup for so long. And Rick is actually, you gotta congratulate Rick. Rick is leading HP, and he's gonna go join VMware. So give Rick a hand for his new job. Yeah. Didn't we just say this about Sean 6 months ago? I guess you can end up at Honda, in another 6 months. But anyway, so my crew is bleeding me, and I'm totally gutted about that. Okay, other announcement. OSCON conference coming up in July. As you know, OSCON is where the foundation is originally created. So you did birthday, they hope that I will be celebrated at large during that week. We will also have an OpenStack 5th birthday party. We're still trying to lock in a venue, so I'm not sure if we're going to have that on, probably going to be a Thursday, but I'm not sure if it's going to be July 16th, due to week 4 OSCON, or July 30th, which to me meant we're going to go close to the end of my Q3, and then the counting faster, so I'm going to the 16th, but then after the consent. Okay. So the state's going to help you at the site. John and I are both going to be here tomorrow, and you will have a new t-shirt. We say it's my 5th birthday at that event. And as well as for those of you that made it last year, you know that it's awesome to see guys. They were an amazing event. And it was a meetup like no other meetup. It was a lot of fun. And we'll do it again this year. So stay tuned for that in about a month in July. Also, there's Silicon Valley. Rantis is leading this and sponsoring it with the foundation, and that's going to be August 26th and 27th, and the day before that, and that's going to be in the Mountain View Tech Center. So it's really very fun. We did a bunch of different conferences and it was a great show. We had a 1-day show last year, it was so good. We're going to do a 2-day show this year. So that's happening in August at the Tech Museum in Mountain View, and the day before that is Trove Day. So this is really cool. This is going to be free. If you sign up for it right now, go through Eventbrite, sign up for it the day before the San Jose. It's an all-day event, I believe, in Kiel to government. Yeah, I was wondering if that actually works for HP. He's the PTO Pro, and he's not going to have office. It's not going to be on speak to you guys at one point, but even better, they decided to do this Trove Day. It's an all-day event about Trove, and everything you probably ever wants to know about Trove from your very advanced topic. The Kiel is going to be one of the centers there. So check out Trove Day, you can sign up for free, and that is the 25th, I believe. So, of August. And one other event, OpenStack event. So, that is next Thursday. So since you guys love doing events on Thursday nights, next Thursday, there's an OpenStack event. And Red Pie, who's sitting right here, every time, okay? Yeah, he's got a flyer, and he can talk to you more about the events. He can pass stuff out. But it's going to be a really good event. 3 different speakers, and everything you ever want to learn about OpenStack. Who knows anything about OpenStack? Not too many, but I highly suggest you guys show up to this one because you're going to learn a lot. And you're obviously interested in networking because you're so speaking of networking, And I see her, she's like, I didn't think it was going to happen.
Thought you forgot me.
And she should have told you. These things, yeah. I don't know, people trickle in, you know, they got to their pizza. There's going to be a lot of people left. I'm not sure how many kids we're going to have to share pizza with. But anyway, Alina won't trust that if you're going to Canada, you're going to pizza today. Because it looks like we actually have enough. So we will not be guarding the pizza. Please don't have your fifth beer. But you can have 5 pieces of pizza. So Brittany, do you have the other one? Okay.
Yes.
So we have guest speakers. Well, they're not exactly guest speakers. They're members of our community. You guys know she's been starting this a lot. And Brittany's going to speak to us today about L4 through L7 services, a deep dive, because this is the advanced session. So I'm going to let you leave you. I actually have to run. But
Thank you.
you're welcome. Take it away. And I'll see you lovely people in either 2 weeks or 4.
Okay.
And Rick, you can run around for questions with this. All right, then I'll finish. Be nice to me, the good guy.
Okay, good evening, everyone. I'm Praveen Yalagandla. I'm the OpenStack architect at avinetworks.com, Avi Networks. We do fully software network services, advanced network services. But today's talk will mostly look at OpenStack networking, particularly looking at the network services and 4.7 network services. So we all know that OpenStack is all about virtualizing hardware resources, right? So for networking, it's basically you have physical network, all your switches, routers, and so on. And the goal for network virtualization in this case is to basically break your physical network and create virtual networks so that your tenants or projects, users in those tenants, they just get to see that they have their own fully virtualized network, that they have their own switch networks full of routers and stuff, their own network. And that's a goal for network virtualization. Now, if you look at the standard L2 SFBay, right? So at the bottom, in the physical world, you have switches and have LANs that define your broadcasting network. In the OpenStack, the neutron network essentially abstracts that out so that you can connect your VMs to your neutron network, and they're all the VMs that are connected to that neutron network. They have they're the same broadcasting, they're like plugging into the same switch. And then there you have in the physical world the routers and your somewhere to IBM, the subnetting, DHCP, and so on and so on, ICANN and so on. On the virtual world of OpenStack, we have a concept of routers and subnets. That's basically where subnets you manage the IP addresses that you are sending to your VMs. And the routers you connect these multiple OpenStack neutron networks together so that you can route from one network to another. But as you go up the stack, so if you think about it in many enterprises or bigger data centers, just it's not, network is not just limited to the switches and routers. You need to, for all the enterprise applications and for real applications, there are a lot more other network services that gets deployed. So in your physical network, there are all these boxes, the real boxes that some people pay, some people know, but they are there. There's like firewalls, VPN as a service, your VPN servers, your load balancers, and so on. And on the neutron side, on the OpenStack side, so there is all these network services, neutron network services products. Each or one of them trying to abstract that out so that you can build these virtual network boxes, virtual middle boxes. So for example, firewall, you have firewall in the service project, for load balancers, there is the RAS project, for DNS, there is designate, and VPN servers, you have the VPN as a service, and so on. So in this presentation, I'm going to mostly focus on load balancing as a service. Mainly because I know mostly about it, and two, because also our I know mostly about it because our company is mostly focused on that side. So, okay, so let me talk a little bit about load balancers. This is a quick overview of what load balancers are, why we care about them, what it needs to be supporting in load balancing as a service, and then we will go on to talk about what's API is defined in the OpenStack, neutron LBAS, the versions of it, and they import it. And then we talk about the implementation architectures and talk about the subnets VM-based architecture. That is the next generation. That's most scalable elastic solution that we have. So let's start with the load balancers. So what are load balancers? So when I was in school, when I was like over my PhD, like in the networking, I was doing distributed systems, but I never heard of load balancers. I never knew of load balancers because when you're in the university, you know, basically you hear about firewall as a service, you know VPN as a service because those are the services you do like impact. You VPN to your VPN server, or you hear that firewall is something, you know that the security one firewalls. But load balancers is one of the things that you don't hear very in the industry. So load balancers are the key for many applications. Like if you're building up any application, you want to have some way to provide high availability and good performance for your application. So if you have a web server that you connect to it and lots of users accessing it, you have this. Let's suppose there are too many users, or your web server goes on. So if you have too many users, then maybe your web server starts to problem, and you will lose. So if the web server dies, you lose your server. So you don't want one single server or single point of failure. So what do? You basically bring up many servers. Now if you have multiple servers, you then need to somehow distribute the traffic of users across it. Basically, you want to give some high availability. So you put what's called these load balancers in front of the servers, and you basically have advertise the IP address that the load balancer has, essentially that load balancer instance has, and then users come to the load balancers and the traffic gets distributed to the servers. So that's the very basic load balancer picture, right? So in this case, if one server goes down, the load balancer is supposed to continuously monitor and just see the health of the backing server, so that it can say, okay, that one's gone, I'm going to not send any more traffic there. And basically take care of the high level. And you can see that basically you get high availability and performance because now you're consuming over the workload across multiple. Now you may ask, isn't that load balancer then your bottleneck for high level? You can go down. Because you have multiple units working as in the panel. You have an active and basically ensure that you don't have any part in your application delivery that is prone to fail. Now, in enterprise, so it's not just the mod that's not so traffic. So it's traffic coming from users. So it's not just that traffic that needs to go fast. In any enterprise real applications, web applications, you have CDK architectures, right? So where you have web server, here with servers, here with application logging, here with database. So all of these need again overlap. So then you have the east-west traffic that's going to these tiers that basically get the overlap. So what the two things I want to say here is that the load balancers actually play a considerably important role in bringing up the enterprise applications. And they handle a lot of traffic that they move to these clouds where there are going to be lots of applications, and people are building applications based on microservices where there's all these services that interact with each other. So there is not just master traffic, that's not just browser traffic coming from outside these applications, but there's a lot of traffic going on in the teams. Now, I want to keep this in mind so that when we talk about like how the arguments of the problem, I want to basically bring up these points and want to say why some architectures are good and scale well and some architectures are not. So that's I have shown very basic simple examples that you are getting user traffic and you're just splitting them across the backend servers. But in reality, there is a lot more is expected out of the load balancer. So over time, initially the load balancer started just basically as the user connections were getting in, you just distribute them out to the backend servers. But slowly, there are more and more features that were needed, and eventually the name that the traditional load balancer companies came up with was application delivery networks. That's the agency name. So there are all these application delivery features, and there is a lot of application delivery intelligence that they're trying to move from backend web servers into these boxes, these single boxes that are running in your labs. So one simple example, like the first one is session persistence. So this is one common example where the users are coming in on processes and user sections in the same bag. So you don't want to have add an item to your cart and then go back to the same page and now it sends you from some other server which is not your another state, then you do that. Or that server like there are many places where your transactions want to go to the same single application logic, so otherwise bad. So one of the main reasons there is that you want to have session persistence, and this actually requires, this means that the load balancers now have to be safe, right? Really to work something about the income actions and be able to process the actions through the same backend. So now there are even more things that people start with. They want not just like load balancing everything across backend, but they want to look inside the request and decide.
Just a moment. Just sorry, a technical issue. Can you switch to the Chromium?
Yeah.
Can you disable your audio?
So as yes. So can you repeat the question again? So
backend server name serves a session. So that if you have an incoming client, the way is established a session, does that client have to go through the same web server?
So it's not necessary in all cases, but there are some applications where the application logic is built with the mind of just running on single server. So people take that application logic and now trying to replicate it on multiple nodes. But those application logics themselves, they kind of assume that like when the user comes in, that there is a continuity in the session. Now that user session gets moved to another web server, another application logic server that doesn't have a state, it kind of starts from the scratch. So this is all very dependent on applications. It's basically a lot of legacy applications that have not thought through to work in this kind of distributed sense. So I'm not talking about like the new age distributed applications where a lot of this logic is taken care of in the building the large scale applications themselves, the Facebooks and Googles and so on. They're okay with just using basic load balancing that just someone's taking the request, they can build their application. But many of the enterprise applications, like they require this sense of the session coming to the same application logic. Okay, so I was talking about the next level kind of things that people want to, yes, one more.
So you are talking about like the session persistence, where the load balancer, you know the state, they will remember the state. So now, like, how much visibility the load balancer should have, is it like all the way to the application? Because
so I'll come to that. So it varies from application to application. That's a good question. So I'll say what it means. So I just wanted to say that people want session persistence, so the requests from same user go to the same server. Now, how do you know that it's a So I'm coming to that. So one of the other things that people want is to be able to send the request based on what's the content in the request. So something like on the right hand side, I see say some very simple example. So let's suppose I have a website, all the requests coming from people who are just browsing the images and browsing the, like looking at the catalog and so on. I would like to send them to just my regular source and regular VMs that are acting as web servers. But once they start to add something into the cart, or when they're going through the checkout session, then I want to send them to these very high quality VMs or servers with SSD and maybe a lot of space CPU and basically huge VMs, so that I don't lose those sessions, I don't lose those users at all in any case. So those are the kind of things that you want to do, like when you're building an application. So those is one more place where these load balancers intelligent load balancing comes into place. So that's policy-based request routing. So in that case, to do that, the load balancers now have to look beyond your just L3 layer, right? Like regularly connection comes, you have access to IP addresses and ports. But if you want to go beyond that, then you need to look inside. So for example, for looking at the HTTP, you need to basically want to terminate the TCP connection. Otherwise, the only thing that you can do is just hand off the connection to someone at the back end, and that connection has to stay. Without otherwise, so you have the load balancer has to do the TCP termination. It wants to look at the HTTP request inside and be able to send it to different servers based on what is there in the request. So this is like one level. Now if you go to the next level, it's not just this termination. Most of the traffic today is SSL, right? You have HTTPS traffic. So what that means is that now the load balancers have to do SSL termination. They have to terminate these SSL handshakes coming from the user, and they have to do these handshakes and maintain this encryption, decryption of the session with the users. So they have to do the SSL termination so that they can look inside the request. And there is one more reason that people want to do the SSL, like more reasons for people to do the SSL termination in the load balancer is because there is basically one central place where they can configure all their policies and so on. And also they want to move out as much of this common logic out of the application into something else. So people don't want to think about SSL when they're building their applications, or do create these processes for handling the SSL on their backend websites. So that's one of the big advantages with basically being able to push this SSL termination onus onto these boxes, middle boxes. So those are all the requirements for the LBAS, for the load balancing. So let's look at the load balancing as a service. What's the status of it in Neutron and so on. So LBAS version 1 API. So there have been 2 versions. LBAS effort started with different project names, almost from I think Folsom Cycle. I think Folsom Cycle was one they started to do it, and by Grizzly, the LBAS version 1 API basically got into the Neutron. So at that point, it was in the Neutron. But the LBAS version 1 API is very simple. I'll show in the following slides. It misses several key features that are required for load balancers that we saw in the previous slides. Something like the SSL support, rules-based switching, and so on. LBAS version 2 API is what is in progress in today's Neutron and the Neutron LBAS team. And this version 2 API has been introduced in Kilo, so it's now out in Kilo. And it's still currently a work in progress. Like there is support for SSL added, but the rule-based switching is not there yet. That's going to come soon. And there's a lot of different implementations, the reference implementations that were added in the code transfer. So let me go through quickly what's there in these LBAS models and then the API. So in the version 1 model, there is this pool, which is the main central object. So pool is basically a pool of servers. That's the backend web service. So you have pool, and you have, like, you define multiple members. Those are like some IP addresses on your VMs. And there is basically the subnet that defines where those backend pool members will come from. And then you have health monitors that you define to say how to monitor these backend members. So it could be, say, just a HTTP server. Then the health monitor would define keep doing a request for /index.html. And if the server doesn't respond to /index.html for 3 times in a row, then mark it down. So that kind of error. So it's a health monitor. It defines basically how to check for the health of the backend members. And then you have this front-end IP address that's called the virtual IP address. That's basically the point that is exposed outside this load balancer instance. Anyone coming from outside will use that IP address to reach this load balancer instance, and then those requests or sessions get distributed across these backend members. So let me show some busy picture here. So it's basically, this is the entity relationship diagram for the LBAS version API. As I said, like pool is the central object here, and you have VIP on the left. That's again associated with the pool. You can't have it as a standalone object. So, and then you have the members that like a pool will have multiple of members, and then you have help monitor defining basically how to monitor your backend members. And there is pool statistics to basically get information about how many bytes in, bytes out, packets in, packets out for that load balancer instance. Now there are multiple load balancing methods defined in the version 1 API, like it could be round robin, least connections, or source IP based. So source IP based, you can hash on the source IP and give it to some backend web server. Least connections, whichever backend server has least connections currently open, and so on. And I mentioned about session persistence. So those are the three things that are currently there in the LBAS version 1 API, which is source IP based on the source IP of the request coming in, or you can based on some HTTP cookie present in the request, or you can do it based on some application level cookie that is inserted by the application. So as I mentioned, this LBAS version 1 module had a lot of things that doesn't meet the requirements for your enterprise grade ADC or the enterprise grade load balancer, like the support for SSL, the rules-based policy switching, and so on. So LBAS version 2 is the next API model that's basically people have been working on. And this one has a lot of new features to overcome some of the things that were missing in version 1 API. So, and also the model has been changed so that pool is not the central object anymore, but you have the load balancer. Clearly, that's defining that's the root for your tree. That's the load balancer, and you can specify which ports that the load balancer is interested in listening in on the listener objects, and then you have the pool and member and so on. Those are the regular ones. The one important thing that got added here is the TLS containers. So that's the SSL support in the version 2 API. Now, one more point about this TLS containers is you can see that there is, instead of putting in your SSL certificate there, because when you want to do SSL termination, you need to provide the load balancer with a SSL certificate that it will present to your end user. Because when you go to any website, the website is going to serve a SSL certificate. That's what your browser is going to encrypt all your traffic, right? Now, the load balancer needs to know what certificate to present the user with if you want to do SSL termination on the load balancer. So one of the things that they have added is basically this TLS container ID. But this TLS container ID is actually a reference to certificates stored in some other external certificate management system. So in OpenStack, there is a new project called Barbican, which is where the certificates will be stored. And here in the load balancer, you just put the ID, some kind of token, some kind of ID here. It's basically UUID for your certificate. And this load balancer is supposed to go and get the real certificate from the Barbican, so that you don't keep those are important secrets, right? So that you don't keep your important secrets around in these services. So that was one important thing here. And as I mentioned, the LBAS version 2 API is still evolving, and there is no support for roles yet in this one. People are working on it to get it in there. So I saw one person.
On the load balancer, does it support this configuration?
Does it support what?
Presenting a truly signed certificate to the external world. On the stack, we have self-signed.
Yeah, so unfortunately, the LBAS version 2 model. Okay, yes. So let me repeat the question. So the question is, here we are talking about just the SSL certificate that load balancer presents to the end user. What about if someone wants to use SSL encryption even on the backend side, from the load balancer towards your backend servers, maybe your local self-signed certificates? Unfortunately, this LBAS version 2 model, this particular one doesn't support that. So the only certificate that you have here is what you present to the user. There is no, so I'll take that back and say one more thing there. So backend, the web server is the one that is providing a certificate to the load balancer. So actually, you don't need to have a certificate here, but there is one case where you want to have a certificate here in the load balancer, which is people started to use the client certificate authentication. That is, basically they want to, like in a corporate environment, when you go to your sites, your laptop is preloaded with your client certificate. That's what you probably renew every year with your IPE, that basically installs one client certificate on your laptop. Without that, you won't be able to access many of the internal services. So if you have applications that are like your backend servers that only accept requests from authorized, authenticated clients, the clients that have this client certificate, then if that is the case, then you need to have the load balancer, you need to provide that certificate to the load balancer so that actually the load balancer can talk to the backend servers. So that is one minor twist there. But otherwise, the backend servers, they will just give whatever certificate that they have, and the load balancer will use that to encrypt and send that out. So, okay. So now let's dive into the implementation architectures, and let's talk about how it's implemented, how we do this.
One question. For every URI, there's a unique certificate. Every URI just has one certificate associated with it.
That's a good question. So I didn't go to the SNI container concept here. So there is default BLS container ID. That's basically the default certificate that the load balancer has, and someone hits it for this port. Now, SNI container ID has something. It has basically support for what's called the SNI, server name identifier. So you can have one single IP address on which multiple websites can be hosted. So something like, say, you have dilbert.com and cni.com, both hosted on the same IP address. So if you go through DNS, both of them will match to the same IP address. But when your browser sends a request, in the HTTP request, it says, I want to get the dilbert.com or I want to get the cni.com, right? So the SNI container is basically, it first identifies the server name. It basically presents during the exchange, there is during the SSL exchange, it tells basically, if you're interested in dilbert.com, then this is the certificate. If you're interested in cni.com, this is the certificate that you want to use. And that's basically SNI container is a way to specify those multiple certificates for these different web servers. Okay, so let's switch to the implementations. So I'll talk about how the implementations and the architecture has evolved over time with respect to implementing the load balancing as a service. So there has been two main implementations that started it. First one was the hypervisor process case. That was the reference LBAS implementation that shipped with OpenStack Neutron when the LBAS version 1 API was released, using HAProxy, which is the open source load balancing software. And then you have the appliance-based implementations. That's basically your traditional ADC vendors, traditional load balancer vendors who have been selling the hardware devices. There, people have them and they want to use them, so they needed a way for to be able to use them. And there were all these LBAS plugins to basically talk with these devices. So that's the appliance-based traditional ADC solutions. So let me quickly go over a little bit of architecture kind of thing with how these implementations are done. So this is the reference implementation based on HAProxy, and on the right-hand side we have compute nodes, all the VMs, and you have controller nodes, the Keystone and Neutron running with LBAS API support, and you have an LBAS driver sitting there. And then you, on the network nodes, you have an LBAS agent running, like your L3 agent, or you may be running DHCP agent on them. So all the networking services related agents that are running on network nodes, right? So in the similar state, there is a LBAS agent running on the network node. And what it does is, whenever there is a request for create a new load balancer, that is a pool and date combination, it spins up a HAProxy process. And then it plugs them into the right networks on the network node, so that the packets can come and go out through that HAProxy instance. So for example, your north-south traffic, it will hit the HAProxy processors, and then it will be load balanced to your backend views. Now, if you have your east-west traffic, basically the traffic has to come all the way from wherever your compute nodes are to the network node and go back to your VMs. This is similar to like the routing happening in the before pre-TDR, distributed virtual routing. So your routers are only there on the network nodes previously, and all the traffic going between different networks, they had to come to your network node and go back, right? So in the case of LBAS, like it's not even related to networks. Whenever the traffic has to go from kind of one tier to another tier, even if they may be on the same network, they still have to come all the way through the network nodes and go back, because that's where your load balancer instance is. So to summarize, there are issues with the reference implementation. So basically, scalability wise, it has limited scalability because it's running on the neutron nodes and creating a large span in there. And as is shown, there is traffic trumpeting because you're kind of getting the traffic all the way from compute nodes back into your rack, running the network nodes, going back there. And you have multiple of these neutron nodes to manage and so on. And high availability actually didn't exist. So high availability in the sense of if your neutron nodes went down, or your rack or your racks that had the neutron nodes went down, then you have basically lost your LBAS. So you lost your traffic to your application. You need basically some other solutions to bring up, like you need to run pacemaker to monitor where each of these load balancers are instantiated, move them around. Like even if one network node goes down, all the load balancers that are being implemented on that network node will go down unless there is some other external process that is monitoring and move them to another network. And finally, one more thing is the tenant isolation. So if you want to have strong tenant isolation, you can't do it because there is only best effort. Like as I shown in the previous picture, they're all shared, or they're all running on the same network nodes. There is no like limiting on what like one process can use. So they're all shared. They're all running on the shared resources. So there is no further SLA that you can really get, and more provision and guarantee, but then that makes sense. So let me move. So just to summarize, it's basically say it's not really suitable for enterprise grade clients. So let me move to the other kind of implementations that people did, which is based on appliances. That is your hardware boxes, your traditional load balancer boxes sitting in your data center, or in the rack next to your all other racks of servers. Now, these appliances are typically sitting outside, right? Like sitting on some other server. And so they are not really plugged into like these virtual networks that are laid out in OpenStack. They are still working outside. So they have to plug into the underlay to be able to get the packets, particularly for east-west traffic, right? Like east-west traffic is, say, if you have VXLAN, then all your traffic is going in these VXLAN tunnels. So be able to, you won't basically, unless you bring the traffic out and you understand the protocol, you won't be able to see anything inside. So if you have these boxes sitting outside and then you plug into the underlay, they need to understand the protocol. So in these cases, north-south traffic typically, like if you may have floating IP that's getting converted into an internal IP, so it will first hit your network node. That's where the thing will be translated, and then you will go out to your load balancer and go back into where your VMs are. So, and if you have east-west traffics, again the same argument here, same thing here, that your VMs are sitting in these compute nodes. They have to go all the way through these load balancers, sitting kind of outside OpenStack and come back. So we can make similar arguments about the appliance-based implementations and the tenant isolation and SLAs. If you want to guarantee, you need to have one or more appliances per tenant and per availability zone. And overall, the OpEx and the CapEx are pretty high because it's all device-centric. Like it's basically device-centric implementation. Then you have to do individual device management. In these, like appliances are sitting external to OpenStack. You have traffic component going on, and you basically have your underlay is something that your load balancer can understand, and basically limited scalability or it will be pretty expensive. So overall, to summarize, it's basically a complex and expensive solution. So what we have been doing and what's the next gen architecture is the service VM architecture. So instead of doing it either of those ways, you basically do everything in service fields. So as I said, like it's basically a distributed load balancer with a centralized control. You have your compute nodes, and this is your legacy where these load balancers either like reference implementation sitting in the neutron nodes or load balancer boxes sitting outside OpenStack. They're basically on the side. Whereas on the right hand side is what we have this next generation architecture, which is basically you're doing all your network services in software, in VMs. And you have some kind of controller that's basically either sitting along with the other OpenStack services or working as VMs or whichever way, is the orchestration point. That's the one that's basically going to talk to your Noah, Neutron, etc. to spin up the VMs in the right places and to spin up as much as needed to basically provide the network service that you're trying to provide. So talk about the basically the implementations that are based on this kind of service VM architecture. So last about a year or so, a new project has started in an OpenStack called Octavia. So where the goal is to basically move from the reference implementation, which has HFRoxy running on the network nodes, to this service VM-based architecture. So I have a picture here from the design of the Octavia. So it's similar in the, with respect to the LBAS implementation that you have the LBAS, you have a driver sitting in the neutron server node. But the key difference is now you have a controller service, that's the Octavia controller service, running on some of the nodes, like any other controller service. And that's the one that basically gets all your API calls. And it has its own database. And it's the one that spins up the service VMs as needed. And on the right-hand side, you have those service VMs, and the term used for the service VMs in case of Octavia are called AMP4. AMP4 is a single service VM, multiple VMs of AMP4. So that's basically, that's the service VM based implementation in OpenStack. So now I'll switch to our architecture. Basically, we have been for the last 1.5 years. We have been building the network services using this virtual machine-based architecture. And let me show you how our architecture looks like. So, in the, as I said, like it's a service VM architecture, and it's you have a controller, which is your central brain, and then you have a distributed set of service VMs, which we call service engines. Now, this, if you think about this, this is like a traditional SDN architecture, right? You have a software-defined network architecture. The core principles are that you make the data plane simple but scalable, and you have a control plane that basically has all the intelligence that can spin up these data plane engines as needed, as many in the right places, and let them do the work, and the control plane do the orchestration. So this is basically the similar spec. So we have a controller that's basically gets all the LBAS configuration, keeps it. It's the self-service model. It has all the support for multi-tenancy and single point of control. And on the bottom, what you have is service engine VMs. Those are the ones that get created on demand, elastically, as many as needed, depending on your traffic and so on. And then will be scaled out, scaled in based on your traffic. Based on the, like if something goes down, you bring up more service VMs to handle the traffic and so on. And we provide basically, you can do the isolation, etc., by creating different service engines for different tenants and all the interesting things. And then once you're doing this, then you have this service VM kind of architecture, and then these service engines are doing the SSL termination, TCP termination, looking inside the application, monitoring the backends. You can actually do a lot more. Like the one thing that we do is something like providing lots of application analytics. So the application, we have built it as an application analytics driven load balancer. So basically you can monitor your application, provide a lot of information about your application. I'll show demo a little bit of pieces of that later in the talk. So let's move on. Yes.
How does the AV control?
How does the AV controller? Yes, so it's AV controller is acting as think it of as same as what Octavia controller is doing. So you have in the LBAS side, a plugin, a driver, and a plugin. That's basically plugin is the one that's doing something right for every API call. In this case, it basically sends the configuration back to the RV control. So
the service VM that you start, are they going to show the virtual machine on that video panel?
welcome. I have some slides. So good question. Keep going.
Are these service VMs inline or one on the balancing one?
Okay. So again, that's a great question. So I'll say, yeah. So the question is, where are these service engine VMs instantiated? Like, are they instantiated on specific nodes or where they are? I'll cover that in the next few slides. Yes. Any other?
What are these like? So the load balancer in the service VM, right? What kind of load balancer? Is it like you said, the reference architecture uses HA proxy? Right?
Yes.
So what are these like? Any third party? Like you have other vendors who provide their own virtualized load balancer?
Yeah, so you can have, so this one is Avi's, this specific one I'm showing the Avi's architecture. So this particular service engines we have built our own, again, based on few of some open source components, but our own network stack for doing the VMs, for doing the load balance. But yeah, so Optivia uses HA proxy, it basically puts the HA proxy in there and wraps around the VM. Okay, so good. So I'll quickly give a view of how the VMs get instantiated and what's going on quickly, just to give an idea of how it works. So particularly for the Avi case, we ignoring some of the details to make it simple to understand. So as I said, like there is a central brain of logic, so that's an Avi controller in this case, and in our architecture, these controllers are also virtual machines, basically, so that you don't need to change your OpenStack environment per se. You're just instantiating. Even this brain has VMs in your on top of OpenStack. And the first thing that an admin has to do is like basically bring up the Avi controller VM and create a management network on which these service engines could connect and talk to the Avi controller. And you provide credentials to Avi controller so that it can talk to no one from, etc., so that it can bring up the instances as needed. Now, let's suppose a user has two servers, those are your application servers that the user wants to load balance to. And then the user configures, calls the LBAS API and says that I want the load balancer for that, for those backend servers. Then what we do is basically create these service engine VMs automatically, dynamically if they don't exist. So and then these are as created as needed for making sure that you have high availability and meet the performance SLA. So if there is a lot of traffic and you have a premium user, basically you can have like the auto scale feature so that the 4 VMs are created as needed and the VMs will be deleted when the traffic goes up. So you don't need to like pre-provision like these many VMs or something.
So are the service engines running on your network nodes? Or
I'll come to that. I'm just here, that's why I said ignoring a lot of details on where those. I'll basically say that in the next few slides. But here I just want to give you an idea of what's going on at a high level to say like where the traffic is flowing and how. So in this case, there is only one network. Your VIP address, virtual IP address is also on the same network. So when the traffic comes in, the service engine grabs that traffic and then it basically splits them out to the backend servers. So that's the regular load balance. Now, in this model, you can have strong isolation between tenants by creating different VMs for these different tenants. Like tenant A gets, the blue tenant gets his own service engines, and the red tenant gets her own service engines. So you can do those kind of things in the service VM architecture that are hard to penetration or
So if there's the service engines all the way down to what you call them something different. Why do you call them service engines?
So because they are network services and load balancers. So load balancers has that term evolved over time. So load balancers, as I said, like people used to call the load balancers when they were simply just spraying the traffic. And then people started to call these intelligent load balancers as advanced delivery controllers, right? Application delivery controllers, ADCs. But actually what we do is even beyond that. So we are doing a lot more network service stuff. So that's why we started to call them service engines, because they are servicing the network traffic instead of just doing the basic load balance.
And can the SC management network be a VXLAN network?
Can be a what?
VXLAN network. Can it be a road
Yeah, it is a VXLAN. It will be a VXLAN network. It will be any network. It's basically from it's all running on top of OpenStack. So these are all your regular OpenStack components, like all the controller service engines. These are all regular VMs, and these are your regular OpenStack networks. So because the greatest strength it has is that it's running on top of OpenStack instead of needing anything in the OpenStack. So it's kind of agnostic to how you build your OpenStack environment, because it's actually doing regular VMs, and it's basically plugged into the right networks and just getting the traffic. So, okay, sorry.
Are you scaling just the load balancers, or are you also scaling the virtual machines that serve the traffic?
We have both, but basically, yeah. We can talk more after the talk.
So you have a tenant, which is a load balancer, but you also have a network controller talking to your SC management to your service engine. Will that network be visible to?
Okay, so I'll come to that in the next. Hold on to that. I'll come to that next those slides. So here, I said, like, I know a lot of details of where these VMs are instantiated and so on. But one thing again I want to point out before I switch to the next slides is it's all VMs and it's all just basically networks. And this being these regular neutron networks and VMs allows a tremendous amount of flexibility with respect to your deployment. It's as flexible as what Nova provides you today. In Nova, you can say, boot up my VM on this specific host connected to these specific networks, or on this set of hosts where I have SSD, or on this set of nodes which has this so and so special property. Whatever like Nova provides, basically in your OpenStack environment, we can use it to basically split up those VMs. So it's as flexible as that. So let me talk about like the flexible deployments this architecture actually allows. So you can have nodes already here. I'm just going to focus on three common cases, which is essence in user context. So on the right-hand side, again, I'm showing that picture where it ignores all the tenants and so on, right? Like you have the OpenStack controller, Savi controller is there as a VM talking to the kind of OpenStack controllers. On the right-hand side, I have two tenants, tenant 1 and tenant 2. And they have server 1, server 2, and tenant 1 that has 2 service engines. The bottom guy has only 1 service engine. Now, if I look at the service engines in users context, this is one mode we can deploy, where Avi controller just sits in the SC management network. We can make the SC management network just private to the this admin or service guy. And we can bring up the service engine VMs in the tenant's context. And those will be visible to the tenant, and those will be accounted for your tenant's resources. So we have one enterprise use case where they want to account the VMs in the tenant's quota, so that it's tenant's resources. If they want a lot of load balancers, let them get enough more places. And we have another case, maybe one public cloud case, where they want to have all SCs in a common service engine, and but still have some exclusive SCs for them to provide like strong isolation guarantees. So you can do that. You can basically instantiate all the service engines inside this common service context, and tenant doesn't even see anything, because all we are doing is plugging into the neutron. They will see those ports, but that's it. They won't see those 2 ports that are connected into the data network of the tenant. Those are the only things that they will see, and they will get the load balancing service. And you have shared SCs, where you basically say you want to use the service engines created in tenant in admin context, and you want to share like the service engines. Basically, these are your say low-cost customers who don't want to pay minimal, and you put them into the shared context, so they will share the service engines. So you can have all these flexible deployment models, and that's like one like real strength that gets out of doing this in the service architecture. Does that cover the questions that people were asking about where this is get deployed and so on? So these SSs are like your regular VMs; they get deployed everywhere. And we have some like you can do a lot of intelligent placement logic there, like depending on where you are. Like if you are load balancing 2 VMs in rack 3, then your load balancer would be placed on rack 3, right? So all those are possible with the service VM architecture. Any questions? Yes.
Question still is why.
So from what I remember, Neutron doesn't allow you to share a particular network. And in this case, the network is logically shared between panel 1 and panel 2.
No, so Neutron, fortunately for us, fortunately for the network service, made a good decision about having someone with admin privilege be able to see all the networks. So if you have admin privileges, you can basically create this VM in Tenet 1, but still plug it into this network that's in some other kind. You can shoot yourself in your foot with doing these kind of things because there is all overlap of IP addresses and these things that you need to take care of. But there is always solutions for that. Right? You create namespaces or something. Basically, your service VM will be able to handle all those cases, right? Because that network and this network may have same IPs, so you need to be able to handle all this and do the right thing. So that's some of the intelligence that we put into the service VMs.
So you have 2 service engines.
So you have 2 service engines, backend logic. How can you do that?
So, well, I'll briefly say about it, and then we can talk more about it at the end of the talk. So, it depends on how the Neutron itself is implemented. The one basic thing that we do is all the traffic comes to the one primary service engine, and that's the one that's doing it as a hierarchical load balancer. So suppose you have 2 service engines, and the goal is to get the traffic and process them on both of these service engines. So suppose you have SSL handshakes, a lot of them SSL connections, right? So a service engine, one core can handle about 400 to 500 SSL handshakes per second, depending on the type of the core and the type of algorithm, maybe more. So in that case, you want to handle more SSL handshakes. If 500 is nothing in a big enough website, then our system basically automatically creates more service engines. The first service engine, the primary service engine, is just getting the traffic and acting as a layer 3 load balancer, essentially, to punt the connections to the secondary worker service engines. Now, in a real physical world, you don't need to do that, right? You can put on router a ECMP rule to say send us connections, distribute them across your 3 load balancers or 4 load balancers. Unfortunately, I'll talk about some of the challenges that we can see in Neutron, and I think as going forward, things will get better. And some of the Neutron plugins are actually implementing some extensions so that you can get this kind of ECMP support. So 2 VMs, I say that I have the same IP address. Some SDN plugins, they can start splitting the traffic to both of those. So once you have those, then actually it becomes even more efficient. Okay, so that's.
Do these service VMs participate in routing to any of the ECMP if you wanted? Any cost?
We'll have to take it offline. So you are asking about basically sending them some kind of BGP updates to the router to get the information, right? To be able to basically do the ECMP. Yeah, we can talk offline about some of the things that we did and what we didn't want to move too much away from Neutron APS either. So we can discuss more. Okay, so I just wanted to show that flexible deployment model still is quite simple when you talk about like a real big, huge OpenStack deployment. So this is one public cloud deployment where we're big enough cloud service provider where we were doing the LBAS implementation there. Now here, even the ARI controllers, they didn't want them to be in the same OpenStack cloud where the tenant VMs will sit, because they want to make it like really secure and so on. So there is a separate OpenStack cloud for keeping the ARI controllers, and then there is a tenant created for creating the service engines there, and then they talk over the basically internet with some like it has to go through some firewall and so on. So we have to look at some ports and so on. But most of the like all the traffic between service engines and AVI controllers are all encrypted as over the SSH protocol, basically the 422. These are all SSH tunnel. So we don't need, like, there is not too much requirements even if you want to do these kind of deployments. So this is one complex deployment that we did for that. Okay, so let me switch and just quickly say that you have all these benefits that you get out of a service VM architecture. So I've shown like the previous reference implementation, like proxy kind of disadvantages. Now, on the right-hand side of the screen, basically you get all the scalability, because now you can do elastic auto-scale based on your traffic. You can automatically spin up and spin down, and you can optimize the placement for your east-west and north-south traffic and all those things. High availability. This is like you can do inbuilt high availability by spinning up multiple service engines for a service, and you can do N+1. And you can automatically correct the SE failures. These are all just regular VMs. So when VM goes down, you bring up another, send you graded your SARs, you're running. And current isolation, you can really ensure strong guarantees by creating different SE VMs per tenant. However, like Neutron and OpenStack, there hasn't been too much focus on the network services from day one. It was mostly for doing the basic tasks. So basically bringing up a VM, connecting it to your network, and getting an IP address and so on. Neutron was one step after Nova networking to give you a lot more flexibility on the network inside. So as we build this service VM, we basically came across several kinds of issues. So just go through quickly two of those. Okay, I'll try to just take a couple of minutes. This is going to now go into a lot of technical details. If you are interested, please come up and we can talk after that. So the two key challenges that we have faced and we had to solve was basically limited number of NICs that each VM can have. In KVM, like you can have 24 vNICs that a VM can have, and the network performance itself. First, let me talk about the limited number of vNICs per VM. Enterprises and so on, they have like thousands of applications. So if you can create only few vNICs per VM, and each of the load balancer requires putting at least one interface on every VM, then we are talking about like hundreds of services, hundreds of VMs to just provide those applications. Your applications may not have too much traffic, but you still need to create so many services. So one solution is basically you do multiple fixed IP addresses per port. But again, the issues were some plugins supported, some plugins don't like multiple IP addresses, and also some plugins don't support, like most plugins don't support same IP address on multiple ports. You can't have the same 10, 10, 10, 10 on 2 ports in your single Neutron network. Now, I was saying because if you have your VIP, for every VIP there is a port created, and that port has this IP address. Now, if you don't want to use that IP address there, but you want to use that IP address on the interface that's already connected to your SC, then you need to either move that IP address from there to here, from your VM's interface. Now, that has associated side effects because suddenly that IP address is lost from that VIP port, and the LBAS gets confused, your floating IP may not work, and all those issues. So one solution, I'll just quickly say the solution for MI2 that we have, we use something called allowed address pair extension that allows VMs to be able to send out traffic with any IP address. Like you can say, it's basically source IP address. It allows you to do source IP address. And then to get the incoming traffic, we do ARPs and video subs so that you can attract the traffic on the service. So there's a lot more details here. If someone is interested. Sure. Yes.
On the previous slide. So I'm working on some other use case. It's not kind of related, but since this came up. So this allowed address pairing, right? Because I'm also running into some similar kind of problem, but I had to go and change the IP table, manipulate, put some load to allow. So is this like a feature which is supported, or it's developed by AVI?
No, it's not developed by us. Actually, this has been in the ML2, in the reference implementation, with ML2 OS or ML2
don't know if it works with VLAN, but it's an extension. It's a Neutron IPA extension, allow data space extension that has been there quite some time. And this basically that you don't need to muck around with idea. This is to allow the traffic to go.
And this is basically depends on what SDN.
Yes.
It is very SDN.
It's specific to who's your Neutron plugin, who's providing. Sorry?
I'm talking about
Yeah, then you can use this. There is some other thing also called port security. That's just about that's got accepted for as the blueprint got accepted, where you can disable the port security on a port so that nothing is checked for that, so that you can receive any traffic and whatever. So, okay, so network performance is another issue again. On the right-hand side picture, if you are been following networking, Neutron, maybe you might have seen this picture. I'm not going to go into the details of it, but just I just put it there to say that there's a lot of layers in the reference implementation on how packets go through in a compute host as they go from VM out onto the physical interface. There are lots of layers. There is a Linux bridge, there is multiple OVS bridges, there are V8 pairs, and so on. So depending on the plugin used, that stack will be different, and depending on how your plugin is, what machines you have, and what versions you are running, you basically can get performance bottlenecks in different places. So, for example, V8 pair was a bottleneck in older kernels, and older OVS had performance issues. 202 that's even shipped with today, people basically moving to 2.2 or 2.3 so that you don't run into those performance issues. And there are net filter connection tracking tracker that basically comes with IP tables that has some limitations. Most of all these are fixable. Like you have to tune your machine. You have to tune your compute nodes so that you can get like good throughput. But in any in any big deployments of OpenStack data commenters, people are quite aware of this and being tuning their network stack so that they can get very good throughput to the nodes. So initially, when we did the service VM architecture, we basically did for both ESX VMware environments and on the OpenStack environments. On a ESX, you can get basically 600 kbps out of the box. You don't need to do anything. Whereas once we did the OpenStack with Ubuntu Overflow, we were getting like 50 kbps, something even small. And we were like, what's going on? And then we had to go through all these issues, finding out where the bottlenecks are. And once you remove all this, like you start to throw away these little things, then you basically can get the raw performance that's possible on your regular x86 stuff. So just wanted to give you an idea of like all these challenges to doing network services, but as we move ahead, the network services can be implemented in software can run on your x86 and can still provide very good throughput, very good network performance. Okay, so I don't know how much time I have left for doing the demos, but I'll quickly show just 5 minutes demo. Let me set it up. Sorry. Okay, I'll just take 5 minutes. Sorry, I have to switch to my personal store because this one, we use the same VPN's subnet as the subnet used for the Wi-Fi here. So
just a reminder, as you leave, please deposit your bottles and cans and paper plates and napkins into the trash cans and not leave them on the table. Also, we have lots of extra pizza, so you get extra credit for taking a box of pizza with you.
So while you're setting up, any questions? Any other questions that line up while you're still setting up the demo? from Avi can answer the question. Yes. Yes, sir.
This may be a dumb question, but when you said the Avi was next generation stuff, did that mean it was LS 2, or is that something different entirely?
So the I think Avi's architecture started before LBAS 2 project was created, but it's a similar architecture. So it's the same service VM-based architecture.
Okay.
So it is not necessarily the same as Octavia, but it's a very similar architecture.
Okay.
Right? Does that answer your question?
Yeah.
Because we've been working on this for over 2 years now, in customer environment for 9 months now.
Is your plugin able to capable and is your plugin able to capable your controller plugin?
The question is the plugin ML2 capable. I'm not sure it's a
Can you repeat that?
So there is the ML2 standard for creating neutron plugins, right? So your controller plugin should plug in into that framework.
So there is a Neutron LBAS driver. LBAS is again another network service that plugs into the Neutron APIs.
Right.
So the Neutron LBAS driver gets the API calls. And the Neutron LBAS driver itself has again plugin concepts. So these different vendors can write their drivers, so LBAS plugin, and then Neutron LBAS driver. Different vendors can write their own drivers. So we have our own drivers for interacting with the computer. Okay, company. You have that? The shift and then there is Google.
Any other questions? Yes.
I have a very dumb question. How is it different from F5?
Okay, the question is how is it different from F5 load balancers? All right, I'll try to answer that as beautiful question as I can. F5 load balancers, so they have hardware load balancers and software virtual machine load balancers, right? Virtual ADCs. The architectures are still monolithic in the sense that the F5 virtual ADCs are not based on this kind of a distributed architecture. You still have to manage them as individual devices. There is no concept of a controller, so there is no separation of control plane and data plane. A VM, virtual ADC is a VM, just a whole ADC. The question is, there's a big IQ similar to a controller, not quite to manager. Again, then we go into competitive discussion that I want to not get here, but we can take that on.
Okay, I have it up. So let me quickly go through 3 minutes of demo. So I logged in as admin here, but I'll switch to the project. So we are in the demo project here, and let me switch to the network. And let me show you the network topology this tenant has. So we have a couple of web servers and their clients, and we can do basically go to the load balancers, and the load balancers tab. I don't. You may have may not have seen it, but it basically has the tabs for pools, members, and monitors, and so on. So you can add a pool that basically shows what are the backend servers and so on. So this the pool, and like we show up as a provider. And then so you pick the subnet, go to HTTP, load balancing method as a round robin. So at this point, this basically is creating the pool, and now we can add members to it. Those will be your, in this case, my demo tenants servers. So I pick the meetup pool, and I want to add the 1 and the 2. And I'll choose, in this case, I'm actually going to choose 443 as the two backend servers as 443 also. So, okay, so the members are added, and you have the pool and members. Now we will do a added fit. So this will, I'll call it subnet. 160, some empty IP address. For front end, we'll pick 443 because I want to do SSL termination also. It's something that we have added. And but still take the protocol here HTTPA because of some limitations in the last version 1 API, which doesn't allow HTTPS in the front end, HTTP in the back end. So once we added, what's going on here? What's going on here is that basically the LVAS plugin sends the configurations to the RD controller, and RD controller talks to the Nova neutron to spin up the service instance. So let me go on to the RD controller just quickly. So here it's all integrated with Keystone, so you can log in with your Keystone credentials, and I'll show. So you can see that it's basically login as demo, and this is basically getting created. So this is the meetup grid that we just created. So we have tools and virtual services. So the meetup pool appeared here. It's 2 backend servers that came up here, and basically the objects that are there in Horizon, the API calls basically gets transferred as API calls here. And the meetup where it shows basically the status of it. So in this case, we are still creating the service engines. Depending on the OpenStack environment, it can take whatever amount of time for the service engine VMs to come up. So if we go to this, and we go to the network topology,
Quick question while I'm waiting for that.
Yeah.
So in a service provider environment where I truly have multi-tenancy, I will need to give a floating IP address to this service VM that I'm creating, so I can direct traffic to it.
No. So I'll show this picture actually shows that. So you can see that service engine VM has one leg in the RD management network so that it can talk to the controller.
Right.
But it has the other leg in this demo network, which is where the front-end traffic is also coming from. So there is no floating IP as such. So you may need to give floating IP to your virtual IP finally, so that you can really get the traffic from outside. But that's basically has nothing to do with whether you are using RP or HA proxy or anything. Basically, there is a web port that gets created. So let me show you the web port.
I'm talking about a neutron router getting logged into the green network over there, which is a tenant network. Right.
So this is the tenant network. Actually, in this case, we are showing it here, but that's the management network. That's basically just to talk to the controller. So this is the main traffic network here. And the traffic network, like you may have a floating IP, you may need to do floating IP if you want to get traffic from outside to your web address. That's 115 address that I created. But that's like any other OpenStack neutron operation. So you have that web port created with that web address, and now you need to associate a floating IP so you can send traffic to that. So yeah, sure. Okay, so you can see that basically we created the service engine. It's plugged into the right networks, and it will basically once it comes up, it needs to talk to the RD controller, do the handshakes, and it will get all the stuff, and then we'll basically have the traffic coming at that point. And let me just switch to here and show one more thing. So this certificate tabs is one of the other things that we added because the version 1 API, as I mentioned, doesn't have any support for certificates. Version 2 API is not fully done yet. We haven't seen anybody really using it at this point because you need the Particle service, which again is itself in some kind of incubation. It hasn't gone, it hasn't matured yet. So the overall LVAS version 2 API, like the usage hasn't been there as much as we would like. So for version 1 API, for people to be able to use, we added the certificate support in Horizon so that people can upload the certificates directly, and the certificate gets uploaded directly to the RE controller. So this Horizon is basically just talking using the REST APIs to send the certificates to the RE controller. And you can go, and we added one more link here to say associate the certificate, so that I can associate the certificate that I uploaded with the virtual service. So in this case, once we do the association, basically load balancer starts to serve that segment. Okay, so let's see. So you can see that we have two service engines created because it's an active virtual service. So in an active virtual service, basically there are two, one acting as a standby if something goes down, and actually, sorry, in this case, active, both of them will serve the traffic. Let's see where it is. Okay.
So one last question.
Yeah.
If you go back to the one in the diagram.
Yeah.
So you say it's active. If it's active, don't you need another load balancer in front of it?
So that's what I said, like one of them is acting as dispatch of the front end. So one of them basically gets the traffic, it gives half from the local enter process and sends out, say, half to the other SC. So the one SC acts as like a dispatcher, that's like the top level load balancer, and again, all of them, it gets distributed.
Minimum 3 services for 2 plus 1 plus 1 right?
Here, it's 1 plus 1 redundancy. You're right. Yes, exactly. So they use keep alive. So if one goes down, the other one takes over quickly. Like if the primary goes down, then the secondary essentially right away sends the gratuitous output to the router so that it can start getting the traffic, and tells the controller that something bad happened to the secondary. The controller spins up one more SC, so you again back into the active. But you don't lose any traffic. I mean, your performance may go down because now instead of 2 service engines, you're basically supported by 1 service engine. But again, there are lots of knobs to tune on to say, always keep some spare capacity so that you can at least get this N+1 all the time, and with certain performance guarantees.
So how many times will the traffic actually keep going?
At most 2 hops, because it's only 2-level hierarchy. So it gets to the primary, and depending on how loaded primary is, it may get to the secondary.
And then again, it will go to the actual server.
Oh yes, that's always the case. So you get the traffic, basically you may get 1 more hop and then get to the secondary. And depending on the placement of your service engines, it's all different. It's little depend on where the service engines are placed. Okay, see. Okay. I just wanted to mark to say that it's working. So let's do I associated the certificate. Oh, sorry.
Can you make it a little bit larger?
Unfortunately, oh yeah, let's see if I can. Control shift plus is not working. So this is whatever that OpenStack console has. So this one basically showing that request went through and it's using the RV default certificate that we got. So the SSL, the certificate that presented by the load balancer is the certificate that we asked it to present. And you can basically send some traffic to it. And just let me show last 1 minute is basically the thing that I mentioned initially, which is there's a lot of application analytics that we do, that we provide on the RV controller. As the traffic is going through, we collect a lot of information about the traffic profiles and so on. So we compute what's the end-to-end timing that users are seeing, what's the kind of latencies that people are seeing. So on the top side, you can see like we don't have too much traffic here, but it kind of shows basically breaks up your application end-to-end network into these different buckets to say where the bottlenecks are. So if someone complains that, okay, my application is not performing well, network is the issue, you can check that there is the app response time and say, no, your backend servers are not responding soon enough. You can see that. So it helps admins and operators to quickly figure out where the bottlenecks are. And we also not only doing this like lots of these analytics, but we also collect like almost like per request level information about stuff going on in the system. So for every request, we get the logs, and these logs are individual request logs about what's happening in the system as the traffic goes by. So I can open the individual of them and it shows per request what is the status of that request, like how wide failed or where it was going and what kind of TLS was used and so on and so on. So there's a lot of application-driven analytics that we do with respect to providing you, like monitoring the anomalies and monitoring your application and providing help report for the applications. Good. I will end here. Okay. Okay, so thanks for coming and attending the meetup. If you have any questions, please shoot me an email or you can basically go to the website. There's a lot more information there. You can apply the product also.
Yeah, I just want to, because just now we talked about open energy. Energy is not open energy, it's open energy. It is a way of the OpenStack is designed for the application, and we begin to open it for the new organization. Where we can complete it under the application. This actually you want to know about how the virtualization can be using OpenStack. And I have a file over there. Thank you. Again, we have extra pizza. Please feel free to take a box of pizza on those here. We have lots of extra pizza. Please take a box of extra pizza. We have 7 extra large t-shirts. That means we have 0 large, 0 medium, 0 small t-shirts. We have 7 extra large t-shirts ready for you to take home. And we have patches and stickers that come as well. Thank you all for coming to the San Francisco Bay OpenStack meetup.